For question 1, we're going to use law of cosines. Trying to find angle A. So with law of cosines, the opposite side, adjacent side, okay, so it's 100 equals 144 plus 256 minus, what is this? 24 times 16, 320 plus 64, 384. So that means cosine angle A is equal to 300 over 384. Now we can simplify this fraction. If you don't simplify it, you'll lose some points. That simplifies to about 12, I guess. Should be 25 over 32. Next question. Here we're going to use law of sines. So this angle is 30 degrees because all the angles have to add up to 180. And so what side length do we know? We know side B, and so that means we can use side B with law of cosines, law of sines. So sine 45 over B, which is 20, equals sine 30 degrees, which is sine A over little a. That means A equals 20 sine 30 over sine 45, which equals 20 times 1/2 over root 2 over 2 equals 10 root 2. Next question, trying to find a unit vector in the direction of this other vector. And so to find a unit vector, we just divide the vector by its own magnitude. And so the magnitude of V is square root of 81 plus 4, which is root 85. So that means the unit vector that we're looking for is 9i minus 2j over root 85. Which we can simplify, and it must be rationalized. Okay, so you could write it in that form. Could have also written it in the bracket form. Next question. Okay, to find a vector of magnitude 5 in the direction of this vector, first we're going to find a unit vector that points in this direction. That's going to have magnitude 1. And then we're going to multiply that unit vector by 5, which will give us a vector of magnitude 5. Okay, so the magnitude of V is square root of 4 plus 9, which is root 13. And so the unit vector pointing in the direction of V will be 2i minus 3j over root 13. And so the vector that we're looking for is just going to be 5 times this vector. Next one, calculate the magnitude and direction angle Magnitude is not hard, right? It's just going to be square root of 9 plus 25, which is root 34. Angle, remember we have the two formulas. So for quadrants 1 and 4, we have arctan y over x. And for quadrants 2 and 3, we have pi plus arctan y over x. Make sure you're able to calculate those arctans accurately. Remember that arctan is always has to be between negative pi over 2 and pi over 2. So that is definitely essential. Alright, so the angle, this is in quadrant 4. And so we're going to use the first formula. It's going to give us arctan negative 5 over 3. Okay. Here, the general formula is that the x and y components are going to be the magnitude times the cosine of the angle, comma, sine of the angle. All right. So the answer is going to be 3 cosine 225 I plus 3 sine 225 I. Sorry, J. 225 is right there, right? 180 plus 45. So those are going to be the x and y coordinates. All right, here we have a physics problem. And so some important things to note. Okay, we have a block, it's weighing 5 newtons, and it's being suspended from the ceiling by 2 ropes. So if our block is represented by this point, then there are 2 forces due to the 2 ropes that are causing it to be suspended from the ceiling. And each rope makes an angle of 30 degrees with the vertical. So this angle is 30, and this angle is 30. Okay, and when it says it weighs 5 newtons, this is quite important, that essentially tells us that there's also a force of gravity that pulls downwards with a force of 5 newtons. Okay, so there are 3 forces in total. We have force T1 and force T2. Okay, and let's say that we're looking for the force of tension in each rope. So in other words, we're looking for the magnitude of these 2 vectors. We're given that it's equal, so that's helpful, but we're looking for what the magnitude is. So suppose the magnitude is given by t, okay? So let's say the magnitude is t for both of those 2 vectors up there. The task now is to split up all 3 of these vectors into x and y components. Okay, and we're going to define positive x to be in this direction and positive y to be in that direction. So let's start with T1. All right, to figure out the x and y components, what you do is you first draw a triangle, right, a relevant right triangle that will give you the x and y components. And then you calculate the length of those components and then determine whether it's positive or negative based on which direction this vector here is pointing. So we know that this vector T1 is pointing left and up. So that tells us that the x component should be negative and the y component is positive. And then we determine the length of these side lengths, and those will correspond to the absolute value. Those will correspond to the absolute value of the components. And then you manually adjust the positive or negativeness of the components depending on what you've already determined to be the sign. Okay. So, for example, T1, we know it points to the left, so x should be negative. But the absolute value of x is given by this side length. And because this hypotenuse is given by t here, we know that the x component should be negative t sine 30. The reason why it's sine is because x is the opposite side. It's the side opposite the angle 30 degrees here. Similarly, the y component is going to be t cosine 30 degrees. And it's positive because this vector here is pointing upwards. Okay? So really the tricky part of this question is getting your sines right and the angles right and the cosines right and the sines right. Okay, just think about it. Okay, for vector t2, we're gonna look and see what the components are. So for this vector, now we're looking at this triangle here. And this is the x component. This is the y component of the vector. We know they both have to be positive because t2 is pointing right and up. And then we can determine the absolute value or the length of these sides using sines and cosines, knowing that the hypotenuse is given by t2. t2 is going to be t sine 30 degrees, comma t cosine 30 degrees. Okay, that's because the opposite side corresponds to the x component, and it's t sine 30, whereas the adjacent side corresponds to the y component, and we know that it's cosine 30 times t. Okay, then finally the force of gravity, which pulls downward, is just going to be 0, negative 5. Okay, so the criteria for this block being suspended is that all the forces have to add to 0 as vectors. Not as numbers, but as vectors. And so that means that all 3 x components must add to 0, and all 3 y components must also add to 0. Okay? The x components certainly do add to 0 because that just cancels out. And so our criteria here is that the y components must add to 0. So 2 times t cosine 30 degrees minus 5 equals 0. Okay? And so 2 times cosine 30 degrees is square root 3. That means root 3t equals 5. And the tension is 5 root 3 over 3 newtons. Next. A fish is attempting to swim south at a speed of 2 meters per second. But due to an ocean current, it ends up swimming at a speed of 3 meters per second in a direction 30 degrees east of south. Okay, so this is V intended. This is V actual. And we're asking ourselves, what is the direction of the velocity of the ocean current? Okay, and so the ocean current is going to be pushing towards the actual velocity. So this is the velocity of the current. Okay? You can imagine the fish is trying to go this way, but it's being pushed that way. And so we have the vector sum V actual equals V intended plus V current. Okay? So V current equals V actual minus V intended. Now we just need to find the components of each vector. So V actual is going to be 3 sine 30 degrees, comma, negative 3 cosine 30 degrees. Right? All I'm doing is I'm looking at this this vector here, v actual, it has a hypotenuse of 3 because its length is 3. And to find the components, I'm just looking at this triangle here. And I know that this angle is 30 degrees. And so that tells me that this length here is 3 cosine 30. And this length here is 3 sine 30. And then I determine the sign, positive or negative, depending on which way this vector is pointing. And this vector is pointing down and to the right. So I know that the y component is negative and the x component is positive. And then v intended is pretty straightforward. It's just 0, comma, negative 2. Okay, so now we can find the current velocity components. It's just going to be v actual minus v intended. So that's 3/2, comma, negative 3 root 3 over 2 plus 2 meters per second. Okay, find the angle between these two vectors. Many people mess this up on the homework checks because this says j and not I. Okay, so the dot product is determined with the y components. So recall the formula, cosine theta equals u dot v over uv. So this is going to equal, right, this is negative 2 comma 5 and 0 comma negative 2, not negative 2 comma 0. So the answer is going to be, the dot product is negative 10, and the magnitude of u is root 29. The magnitude of v is 2. So that gives us negative 5 root 29 over 29. So theta is arc cosine negative 5 root 29 over 29. Next question. Here we can just rearrange that equation we had before, which will tell us that u dot v equals magnitude u, magnitude v, cosine theta. So that's just 2 times 5 cosine 5 pi over 6. That's 2 times 5 times negative root 3 over 2 equals negative 5 root 3. Okay, let's calculate the trigonometric form of this complex number. That requires us to first find the magnitude and then factor it out, kind of. So the magnitude of this complex number is 3 squared plus root 3 squared. That's root 12, which is 2 root 3. All right, and then if we factor that out, we're going to get root 3 over 2 minus 1/2 I. Okay, root 3 over 2, comma, negative 2. Where is that on the coordinate plane? It's going to be right here, so that's an angle of 11 pi over 6. So this will be our trigonometric form. Make sure that this says plus. So you have to know your unit circle angles very well in order to find this quickly. All right, and so how would I plot this? When you're plotting it, just make sure it's in the right quadrant, close to the right axis. Maybe label an angle and a magnitude. That's enough. Okay, this in standard form, that's not part. You just calculate these trig functions. And standard form does need to be expanded, so this will give you negative 3/2 plus root 3 over 2i. And plotting it on the complex plane, just think about the angle and the magnitude. So 5 pi over 6 is there. this is root 3. Okay, here we're going to use Euler's formula to calculate this. So you should convert each one of these to exponential form, and then you'll see that the angles just add. So the first one is e to the I times 5 pi over 3, and so on. And when you add these, you should get 7 pi over 3, I think, if I'm not mistaken. Yeah, sounds about right. Okay, and 7 pi over 3 is the same angle as pi over 3, because 7 pi over 3 minus 2 pi is pi over 3. We're allowed to subtract multiples of 2 pi, remember? So this is going to be cosine pi over 3 plus I sine pi over 3, which is 1/2 plus root 3 over 2i. Next one, very similar. Now we're just doing division. Right, this is e to the power of I times 4 pi over 3 divided by e to the power of I times pi over 6. Okay, and that's, now we just subtract the fractions, which will give us 7 pi over 6, I think. Yeah. Which is cosine 7 pi over 6 plus I sine 7 pi over 6, which is negative root 3 over 2 minus 1/2 I. I think. Next one. Looks like we're going to use De Moivre's theorem. First, let's write it into trigonometric form. That's always the first step. That'll give us the right angles with which to apply that theorem. So that means we're going to have to factor out the magnitude to get trigonometric form. So the magnitude is 2, right? 1 plus 3, 4, and square root. So it's 2 times 1/2 minus root 3 over 2i, all to the power of 7. Now we can write this in trigonometric form. I'm also going to split up the exponents, and I'm going to get, what angle is this? 5 pi over 3? So this is cosine 5 pi over 3 plus I sine 5 pi over 3. To the 7th power. 2 to the 7th is 128. And now I applied De Moivre's theorem, which means I can just distribute that power to the angles. So I'll have cosine 35 pi over 3 plus I sine 35 pi over 3. Now 35 pi over 3 is equal to 5 pi over 3. Subtract 10 pi. So that is going to be 128 times 1/2 minus root 3 over 2i, which is 64 minus 64 root 3i. Next one, also De Moivre's theorem. I'm going to factor out the magnitude, which is 3 root 2, which leaves us with negative root 2 plus root 2 over 2i. And get the angles out. So this is 3 pi over 4. Now we can apply De Moivre's theorem. 1 times 4, 324. And then cosine 3 pi is -1, and sine 3 pi is 0. So this is -324. Okay, last question, finally. Find all the solutions to this thing in trigonometric form. So, right, remember the formula. I'm not going to write it out, so I just hope it's in your notes. The formula requires us to first write this in exponential form. Okay, so remember exponential form is the radius or magnitude times e to the I theta, where theta is the angle. So radius is magnitude, and the magnitude of this is clearly going to be positive 64. So we have positive 64 times 0 minus I, or 0 plus -1I, whatever. And then what angle is that going to be? You can just plot that on the plane. Negative I is right here, so that's an angle of 3 pi over 2. So this is going to be equal to 64 times e to the power of I times 3 pi over 2. Okay, so that means we're trying to solve z to the 6th equals 64 e to the I 3 pi over 2. Now that means that z equals 2, right? 2 is the 6th root of 64. And then we have e to the power of I times, here I'm going to now divide this angle by 6, because it's kind of like I'm raising both sides to the 1/6 power. So 3 pi over 2 divided by 6 is pi over 4. Okay, you can convert that yourself. 3 pi over 12, pi over 4, and then plus 2 pi k over n, which is 6. Okay, and so that's going to be my answer, where k equals 0, or 1, 2, 3, 4, or 5. Okay, so I get all 6 answers just by plugging in those values of k. So for k equals 0, I'm going to get 2e to the I pi over 4. And in trigonometric form, that is 2 times cosine pi over 4 plus I sine pi over 4. The question just asked for trigonometric form, so I can leave it like that. If it's 1, then I have 2e to the I pi over 4 plus pi over 3. Which is 2 cosine 7 pi over 12 plus I sine 7 pi over 12, or 2. I'm going to have 2 pi over 3 now, which is going to give me 11 pi over 12. We have pi over 4 plus just pi. So it's 2 cosine 5 pi over 4. So it's very tedious. Shouldn't have chosen such a large power for this question. 19 pi over 12. So those are our 6 answers. Some of them you can simplify, but the ones over 12 you can't. So plotting them, when you plot them, it's quite important to make sure that you have everything in the right quadrant. So it'll be good to think about which ones are less than or greater than pi over 2, pi, 3 pi over 2, etc. Okay, so 2 cosine pi over 4, that's easy. It's just 45 degrees. And then we also have the opposing one, which is 5 pi over 4. And then you can just make sure you're kind of spacing the remaining ones evenly. So 7 pi over 12 is pi over 2 plus pi over 12, so that'll be right here. Very close to the here. And there's one going to be opposite that. Then 11 pi over 12 is right here. And that would be your sketch. You can label the length, which is 2. And that's good enough.